Good morning, ladies and gentlemen. I'd like to welcome you to the second day of the Eye on Earth Symposium 2018. My name's Libby Hepburn, and I've been invited to make a short introduction to this session here. My background is with citizen science, both in Australia and in Europe, and I'm helping to work with the Global Citizen Science Partnership. And the reason that I've come to this session is because I'm really interested to see how something like the data cube works, how it can work for everybody to be able to see what's there. And I'm also very interested, particularly personally, to have a look at and see how civil society and citizen science can be involved in this. It's a huge opportunity to come to the Eye on Earth Symposium. It's my first physical visit. I've watched it online before, but I'm delighted to be able to be here and thank the organizers for the opportunity for everyone to come together and talk to each other and find out how much we can do together and how much we can collaborate. So this session is about the African Regional Data Cube, and it's a brand new tool that's been launched only a few months ago. And it's across Kenya, Senegal, Sierra Leone, Ghana, and Tanzania. And it's been established particularly to address food security issues as well as other issues relating to agriculture, deforestation, and water access. And what's impressive about this is that it was developed by the Committee of Earth Observation Satellites and NASA in partnership with the Group on Earth Observations, Amazon Web Services, Strathmore University in Kenya, the Office of the Deputy President of Kenya, and the Global Partnership for Sustainable Development Data. So it's a brilliant example of real collaboration across private, public, and civil society. And we're going to hear from a number of those countries about the data cube and their plans for using it. And I'd like to first welcome the first speaker and MC session of the session, Steve Ramage, Group on Earth Observation. Steve.
Thank you very much. Good morning. Oh, we'll try again. Good morning. Good morning. Yes, right. That's how we're going to continue. So if you speak French, you can call me Monsieur Ramage. And if you don't, then just call me Stephen. So I'm going to try and set the scene so that Brian can really explain the technology, the technical stuff, and how this really benefits everyone doing the SDGs. if I start with GEO, the Group on Earth Observations, because that's who pays my bills. GEO was created more than a decade ago, and part of the reason for GEO was to move much faster than the UN. So to be able to have a decision-making place for countries relating to Earth observations. So helping countries to understand the value and usefulness of Earth observations for research policy and decision-making, with real emphasis on the broad access and open data sharing for Earth observations. So everything we've been doing for the last decade has all been about providing access to open Earth observation data and information. Now, the whole ethos behind that has been to build this thing called the Global Earth Observation System of Systems, which has been shortened to GEOS, thankfully. And in building GEOS, we've been collecting data from around the world. So when we talk about Earth observations, we're talking about anything in, on, or around the Earth. So we're talking about satellite imagery, but we're also talking about data that's collected in place, in situ data. And so that could be relating to the ocean, that could be terrestrial data, that could be atmospheric data. So that's really the role of GEO. That's what we do. We bring together lots of organizations to talk about a number of different things relating to the science, the technology, and in particular the policy. And some of the successes have been at the GEO plenary in 2007, my former boss, Barb Ryan, announced that Landsat was going to be made open data. So that was really a milestone in terms of where the industry's gone, and in terms of probably one of the biggest announcements around open data. And that was ahead of the curve as well, because I think a lot of organizations and a lot of countries have only really got into open data in the last maybe 4 or 5 years. As a result of that, I think it's fair to say that Europe and other parts of the world have followed that activity. So we now have the Copernicus program in Europe. And if you listen to what the European Commission says, is that they follow the GEO data principles. So we have data sharing principles and data management principles, all about open, accessible, freely available Earth observation data and information. And those follow the FAIR principles. Has anybody not heard of the FAIR principles? So everyone knows what FAIR means. So findable, accessible, interoperable, and reusable. So those are the principles that we abide by. And those are basically science principles that we follow in everything that we do. So to do all of this work, and bearing in mind when we started, it was nothing near the number of countries we have now. So now we're over 100 countries. And in some ways it's a little bit like herding cats, because everyone has a different way of doing things. People have different descriptions of things, particularly in terms of language and in terms of things like semantics and ontologies. So that's part of the role of GEO, is bringing all of this together. We have a work program that is there to help do this. And in the work program, there are over 70 activities. But what we're doing at the moment is a review to focus on 10 of those activities and do something quite new for GEO, which is really think about putting much larger sums of money into a much smaller number of projects. So I'll come back to that when I come to the end of what I'm talking about. So one of the countries that has been very active in GEO from the beginning is Australia. And so Australia have, the way we try to work GEO is we try to get multiple different agencies in a country to work together, so that we have the Space Agency working with the Ministry of Environment, working with the National Office of Statistics, working with the Department of Science and Technology. Now, for those of you who either work with government or come from government, you know that is not an easy task. But this is really what we're trying to do. And I should add in here, this is probably where our partnership with GPSDD is strongest, because I think that's where they add the greatest value, is talking to the policymakers and helping us distill some of our technology and technical messages. So we've been doing that. And if you look at some of the countries, so like in America, we have isGEO, we have Canada Geo, we have UK Geo. Some of these countries will come to our plenary with a dozen organizations. I know the UK came with a dozen organizations. And if you take 100 countries and multiply it by a dozen, well, you very quickly hit 1,000. And so we estimate there's something like 1,000 national government agencies in the network. Not all active, but they're all there. I mean, NASA is one of them. And look at the size of NASA. So it's a very, very big network. And my first involvement at Eye on Earth was to sit on a panel. I'll just tell you a quick story. Bill Clinton did the opening for the session, and I was at the end of it doing the closing on a session on Network of Networks. And my mother saw the agenda, and she photocopied it and told the whole family I was on stage with Bill Clinton. So that was my first exposure to Eye on Earth, and I wasn't at all. Bill Clinton got paid lots of money, and I didn't. So going back to Australia, if you look at what I was saying about open data policy, and you look at where we are today with things like cloud services, open system architectures, the ability to share algorithms, things like GitHub, the willingness of the community, all of these things came together for Australia about 4 or 5 years ago. And what they wanted to do was capitalize on that and take the open data from kind of the 80s. So Landsat's been around since about 1972, I think. So take that from the 80s and take it across the whole of Australia and use it for very specific thematic areas. So one of the first things they did was called WAFs, and you have to say it with an Australian accent for it to sound authentic, but water observations from space. And so they did this work, and they took all of the algorithms and the code, and they made everything open source. They made it publicly available. And the original activity in Australia was called the Australian Data Cube. But when you're trying to get money from politicians, that doesn't fly. So they called it Digital Earth Australia, and they got some money. So they moved it, and they put all of this code available, and now it's known as the Open Data Cube. And so opendatacube.org is where you can go and you can find all the information. Now, after that was done, the Committee on Earth Observation Satellites, and there will be a test on the acronyms, by the way. The Committee on Earth Observation Satellites, CEOS, with Brian and a whole pile of other people, but mainly led by Brian, picked up on the work of the Open Data Cube, and they started to develop this, and they started to work with countries on what was happening. You still following me? Right. Then our friend Mr. Aditya Agrawal from D4D Insights, formerly GPSDD, was working with Brian to do something in Africa. So GPSDD has been doing lots of work with countries around these country roadmaps and around the requirements. I guess 7 or 10 countries worldwide to start with. And so Aditya and Brian started talking about what could be done in the countries based on these requirements. So they came up with the Africa Regional Data Cube, which is what you're going to hear more about today. Now, the important thing about this is everything that's being done is to produce analysis-ready data. So this ARD makes it much easier for people to use the data. So yesterday I was on a panel session with Jed Sunwall from Amazon, and Amazon have a term called undifferentiated heavy lifting. Really easy to remember. And what that means is they want to find a way to lower the cost of entry and use for data. And the undifferentiated heavy lifting is all the stuff that has to go before using the data. So when Brian and I had lunch yesterday, Brian was telling me that through the Africa Regional Data Cube and the work that's been done, something that could have taken a month and a half now takes 15 minutes. So think about that in terms of productivity gains, in terms of how that frees up and how that makes things easier to do. So that's one of the messages around the Africa Regional Data Cube, what it's facilitating, what it's enabling. The other thing is bringing together the different countries to collaborate. And I'm sure Davis will pull this out in his session, so I won't talk about too much about that. But one of the things that if you look at interoperability, one of the terms that doesn't really exist is human interoperability. And this is something I've been trying to push. It's a really rubbish term because it's a techie term, but it's the collaboration, the cooperation, getting people to talk more about motivation and behavior, because those are the things that really drive change. And those are the things that we need to get the policymakers and others to buy into. So this is really what I believe the Africa Regional Data Cube is enabling. And it's moving very fast, and you're going to hear that from Brian and from Davis later on. But I think it's very impressive if you look at when it started to where it's reached right now. The progress is quite staggering. And we did the official launch in May in Kenya. And I think since then it's gone incredibly fast. And Brian will show like the activities and what's coming out of it. So that has been for 5 countries: Sierra Leone, Senegal, Kenya, Tanzania, and Ghana. Did I get that right? Yes. Yeah, thank you. And what we're trying to do now, if you remember, I said within GEO, one of the things we're doing is looking at trying to do more projects and raise some larger sums of money. What we're doing now is we're looking at something called Digital Earth Africa. So remember right at the beginning I talked about Digital Earth Australia. The Australian government has now funded that to the tune of over $100 million. And they've already had 40 million of that given to them, allocated to them. So this is very real. This is something that is playing into the long-term planetary sustainability from an Australian perspective. And it's a big investment from the Australian government. What we're looking at now is building on the Africa Regional Data Cube and building Digital Earth Africa. And so we will build a continental scale solution for the data cube. So the Africa Regional Data Cube is the foundation for that activity. So we'll be learning from it. We'll be using, it will be the same code. It's all based on the Open Data Cube. And so there we're looking to raise something in the region of $50 million, because we're going to do that as not a 3-year project, jump in and then leave again, but a 15 to 20-year program, and hopefully much longer. Now, within GEO, because I mentioned GEOS, this Global Earth Observation System of Systems, one of the things we've done is around each global region is we have regional entities who work together. So in Africa, we have AfriGEOS. And AfriGEOS is something like 30 countries in Africa who already work. So we have the 5 countries who are already in the Africa Regional Data Cube, and a couple of them are already in AfriGEOS, and then we have all the countries in AfriGEOS. And the idea is we'll use that to build up the community activity. At the same time, we're looking at the institutional hosting arrangements, and we're looking at how can we make this. So AfriGEOS is all about Earth observations in Africa by Africans for Africa. And so that's the same concept for Digital Earth Africa, is when we get the funding, everything will be based in Africa and managed by people locally there. So that's kind of the backstory. I think we've raised about half of the money, so it's looking quite real now. Fingers crossed. I don't want to say much more because that's like the curse of death if I say it and then it doesn't happen. But there's nothing, once we've done this, there's nothing to stop us then going beyond and doing Digital Earth Latin America, Digital Earth Asia Pacific, Digital Earth Middle East or Arab states. And that's kind of where we're thinking, because GEO has the reach, we have the memberships, we have the mandate. And next year in Australia, we're holding a ministerial meeting. So we will have ministers coming to look at our strategic plan and give us guidance for the next 4 to 5 years. So that's a little bit about GEO. That's a little bit about how we're supporting the Africa Regional Data Cube and Digital Earth Africa. CEOS, the Committee on Earth Observation Satellites, is what we describe as the space arm of GEO. So that then provides me with a nice segue to introduce Dr. Brian Killough, who is an applied physicist He's actually an engineer, but don't hold that against him. Brian has been at NASA for, I guess, as long as GEO has existed, more or less. And he's kind of like he's really pushing this within CEOS, but also within the much broader community. So if any of you follow Twitter and you saw the tweet I posted about this event last night, Brian's the one who's working on the 50 countries who are looking at the Open Data Cube. So we need to find a way to clone Brian. So if anyone knows how to do that, we can. Before Brian comes up to speak, I'd just say Brian has a keen interest in underwater zoos and wandering around malls trying to find as many different activities as he can. So Brian, would you like to come up and share with us your information?
That was a nice intro. Thanks, Stephen. Stephen gave you a great context for where all this came from. My job is to tell you a little bit more about this thing called a data cube, what it means from a technology perspective, as well as what it can do for all of us around the world and supporting sustainable development goals. So I'm happy to be the one to tell this story, but some people call me Dr. Data Cube and others have some strange names for me. My family doesn't want to clone me, incidentally. One is enough. So what are these things called data cubes? It's interesting. It's important that you know what they are generally, just so that you can have an understanding of the power of all of this coming together. So years ago, all we ever dealt with were these things called scenes. They're basically flat files, imagery files, a particular point in time, about 185 kilometers square, and those were the Landsat scenes. You would download these monsters, and they would take you hours and hours and hours, and you pull them together and you do your analysis. It was very difficult. Imagine taking 8,000 of these scenes, which are multiple gigabyte files, and I pull out the pixels. Now the pixel is the smallest spatial bit of resolution within those scenes that you can see. It's about the size of this room that we're in, would be a pixel. That's what we can see from space. Pull out all those pixels in the scenes, thousands of those, and then stack them into a cube. And I want you to think of the cube has spatial dimensions, X and Y spatial dimensions, and a time dimension. So as data and satellite are taking data over time, pull those pixels out for any given region and any given time period, and we can stack them nicely in these things called cubes, data cubes. So what it does is it takes this complexity of scenes with overlapping edges and all kinds of computational complexity. I pull them together and I stack them in these nice cubes. I can data compress them. So when I go to store them, I need 8 times less storage. Pull all that together, we have a lot of power. Now combine that with putting it in the cloud and taking advantage of today's modern cloud computing, and we can do a lot with this data. So Stephen told my little story about the punchline of the time that's saved in all of this, and it was just last week having a training session with Tanzania. We finished a 15-minute segment on creating a cloud-free mosaic with which basically removing the clouds from a stack of scenes over time, creating this nice clean image that they can use for mapping purposes. And he said, oh, that would have taken me far more than a month, and we did it in 15 minutes. It's that's the power of what we have. So why do we do all this? What are some of the advantages? And I've told you about the advantages of data preparation. That's an obvious one. We can query those cubes, and what happens is once it's in this nice stacked format, I can query that data spatially, and I can query it in time, and I can write algorithms to do things that are computationally very fast and efficient. Everything we're doing in this project is free and open source. So if you want to see the code behind this, it's all open source. If you want to redesign the user interface that sits on top of the cube, you can do that too. And this is the power from the data itself being open and available to anybody, as well as the source code. That's very important in the world we live in. Though I can't stand this, frankly, in my community when someone produces this beautiful result and they won't give me the algorithm. How did you do that? Well, it's great. It's just a fantastic product. You should just believe me. I won't name the names, but I don't like those people. So also, this Open Data Cube community, we are truly trying to make this a community. We would like people from around the world to help contribute back into this community and to make it more viable and help the next country or the next user. So when an algorithm, recently we developed a change detection algorithm in Colombia for forestry. We're able to share that algorithm with others. Now, will it work perfectly in other parts of the world? Maybe not. But the fact that they share that algorithm and make it available, it's probably going to work well in people with similar forest structures and things like Colombia. Efficient time series, data interoperability. So think about now in the data cube, if I have all these pixels stacked and I pull in some Landsat data, which is optical data, think of it as things we can see with the human eye. I can actually make sense of it if I was in space and looking. Combine that with radar data, which you really can't see with the human eye, but it penetrates the clouds. Well, what if I brought those two data sets together? I can use them interoperably. This is not really possible years ago. Years ago, it's very difficult to combine two disparate data sets, pull them together in a single algorithm and to do something exciting. Now we can do that because in the data cube construct, we can align those pixels and the user may not know the difference. But wouldn't it be great if a radar chunk of data can fill in a gap when a place like DRC in Africa doesn't get a clear scene for 6 months a year? 6 months a year, they don't see the ground, it's cloudy. Well, if you're trying to track the trees, I think you need some radar data for that. And lastly, it works, and it shows that in Australia. They have had tremendous success. And a bunch of us came together a few years ago, and I saw that success in Australia, and we got this conversation going in CEOS, and I said, why not globalize this? This could definitely be used across the world. Let's think about how to do it, and that's how all this was born. So now we've moved along and look at how many cubes we have around the world. It's really just an interesting combination. We're at about 50 countries now. 9 of these cubes are in operation, 5 of which are in the Central Africa and that African Regional Data Cube. You know, we have, I like to call them the godfather of data cubes. There's our friends in Australia. And we have Colombia and Switzerland. And you know, a few of these cubes are growing completely organically. I have nothing to do with them. Just a week ago, I got an email from somebody who said, I want to let you know that I just won, this is in the UK, I just won a partnership project in IPP. We're going to build a data cube for Mongolia, and we're going to help them do it themselves. So I have nothing to do with this. Nobody in our ODC community had anything to do with this, but UK Catapult understands the data cube. They've got a project in Ghana. They put in another proposal, and they said we're going to build something for Mongolia. I think that's really exciting because then all the processes and things that they use can all be shared. So how can we use these things? Once we have all that data stacked in a nice, efficient way, we can now run a number of algorithms and really create some exciting products. So what I'm going to show you from this point forward are some really exciting products that I think will tackle the SDGs very nicely. And when I show you beyond the algorithms, this is sort of the technical background of the things we can do. I want you to think about each one of these things tells a really tremendous story. And I think this data, when brought together and analyzed and pulled into a format that's understandable, we tell a tremendous story. And it's those stories that are going to impact decision-making and change things at government level and at local levels. These are a number of the algorithms that we have. It's about 20 or 30 core algorithms. So we can do cloud-free mosaicing, which is basically removing the clouds from optical data, spectral indices like vegetation indices and fractional cover, and NDVI, which is a build-up index for urbanization, land classification, water. He mentioned WAFs. I wish I could say it with an Australian accent, but I cannot. Sentinel-1 was SARD. This was fantastic. So a year ago, I brought in a summer student from Yale University and said, could you build, this kid wanted to do machine learning. I said, could you build a machine learning algorithm for Sentinel-1 data to detect water and test it? So he took Landsat data with some known water, very high probability of seeing the water, combined it with Sentinel-1, created this algorithm called WASARD. It's a machine learning algorithm that does a great job of detecting water with radar. And you've got water quality and land change. So all of these things create some exciting, colorful products. Wait till you see these products. They're really colorful. So let's move on to some of these cool products. So this one in particular, so I make references in all of these to the SDGs. So I just want you to know there is a particular focus on SDGs for all of these. And so my goal is to try to build algorithms that can get us close to answering the specific indicator requirements. This is actually, and I just did this a couple days ago when we had a little collaboration on the weekend, Saturday and Sunday. We got together with some of the countries and I was playing around and I stumbled across this dam near Nairobi called the Masinga Dam. And I said, let me run something. Let's test this out. Just a couple minute analysis. This is basically the water quality variability over 4 years in this dam. So if you are a local, with a local government and you're interested in the water quality in this dam, you're likely going to want to sample the water. Well, wouldn't it be nice to know where to sample the water? Where is the variability? Where is the best places to sample? Dark is bad, lighter colors are cleaner. And lots of variability here, right? So this is not a great spot. So it's likely having quite a lot of variability here. So if I scatter my sampling throughout this dam, I'll get a much better indication of what's happening. This concept right here, we actually did in Uruguay. Uruguay was taking water samples sort of haphazardly, randomly across a reservoir that was providing drinking water for Montevideo. And they had no real plan on how they were doing it. I showed them one of these and they were amazed because first thing she said as she looked at it says, oh boy, we need to adjust our water sampling. And then imagine this, she gave me 2 years of data and said, could you take a look at this and see how it compares with some of the Landsat data? In 2 years, only one sample, there's probably 100 of them, only one sample was coincident with a clear Landsat scene. So they basically were taking water samples on the wrong days. Water quality changes quite rapidly, and you would really love to get the water quality sample on the day of the satellite overpass. You could do nice calibration at that point. And that's the kind of validation data we need. Stuff like this can help them change how they analyze the water. So how about water extent? This is another, I would call this one probably the easiest SDG that we can do with the data cube. But the way we do this is you must look at the time series. So I go through the entire time series, and what I'm asking it is for this particular pixel about the size of this room, what is the fraction of time this pixel was water over the time history? Well, things change, right? Things change with coastal erosion. Things change with lakes drying up. Perfect example, Lake Salonga in Tanzania. This lake in 17 years has completely dried, really terribly so. The area in blue is water the entire time. Now, those little streaks that you see is it's an unfortunate artifact of the Landsat satellite. It has a problem with its sensor. So you get a few streaks through the data. But I will certainly say, whether you believe the quantitative answer of 62%, I'll bet you qualitatively it's pretty darn close. You can go there and see it for sure. That lake bed, all of the area in red, used to be water 17 years ago, is now no longer water. The only area that's increasing in water are those few little green patches up in the corner. Well, that's probably just low-lying areas that are now holding water during the rainy season. So this is really interesting. And we found other areas. Yes, ma'am. Oh, I didn't. I'm yapping into this. I probably don't need a microphone. So let's move on. Urbanization. This one's also quite exciting. So we did an analysis for Sierra Leone in the Freetown. So Freetown is a peninsula. To the left there is the ocean, and then the water wraps around that peninsula to the top. So this is the capital. It's growing rapidly. All of the pixels in red are basically urbanized areas. And look at the difference between 2001 and 2017. So you can easily do these analyses. And what you do is, what we need to do is validate some of the data. So when you do these analyses in the algorithms, there's no perfect algorithm. The first time I run an algorithm, I try to look for urbanization. It's not ideal. So you have to play with the data a little bit and get it to validate it with some known information. Then once it's validated and you say, this product looks right, it's matching some maps, I think it's correct. Now I'll apply it over a longer time period and I'll start to see the scale of change. So here's what's interesting. This story here, which, the punchline at the bottom is, what is this telling us? If I look at this change in urbanization, this area grew 150% in the area that was urbanized, yet the population only grew 80% in the same time period. What it means are people are moving out of the cities and overtaking more land and spreading out rapidly. The whole area in the center region is all forests. Well, that forest is completely being lost. So these areas along here and along here were all deforested in that 17-year time period. So the people in Sierra Leone are moving out of the city, outward, taking over land, taking over forests. Now, that may be a reasonable thing for the local decision makers, but they have to be concerned with their natural resources. Is there enough farmland being retained for these people? Are we deforesting at a rapid rate haphazardly? And understanding this and controlling this and having a knowledge of where it's going is really important. So let's look at deforestation. So 15.1.1 has to do with forest area. How well can I detect forest area? There are a lot of really fancy algorithms out there for forestry, but I can come pretty darn close with some really simple vegetation analyses, and I call it vegetation threshold. So if I take NDVI, which is this little fancy combination of Landsat bands, which just measures the greenness of the vegetation, and I look at the maximum vegetation from year to year, and I put a little threshold around it, I can get forests pretty darn close. The image on the top right is Matt Hansen's Global Forest Watch. This is one of those wonderful algorithms that nobody knows what it is. If anybody knows, let me know, because he won't tell us. But that's the answer on the right. It's the only global forest loss product that you will find out on the web. It's a fantastic bit of data. It's great. You can go in there, you can query down to the lowest level, and I actually use it as a validation test for, am I getting the right answers? Well, the data cube answer is on the left-hand side. So the difference between what Matt is doing, Matt actually classifies the land to start with as forests. When I do a vegetation change on the left, all I'm looking for is change in vegetation. It could have been a grassland that basically went dry and changed. All I'm saying is I'll show you where all of the areas have been devegetated or the greenness has lost considerably. And in areas that we generally know are forests, it does a good job. I would say those two are pretty darn close. And so that tells me that this does a good job. If you want to find out where the deforestation is happening, and you want to do it from a control perspective, you're going out and investigating what's happening, maybe just getting a scale map of what is the rate of change of deforestation. What I often find is the scientists, and I see this in my community, they get caught up in the numbers. They get caught up in, well, is my forest loss 13% or 14.8%? Who cares? It's more than 10%, and it's happening. So we need to get an idea of what is the impact of that. It's not a matter of counting the individual trees. It's a matter of understanding the impact to society or the impact to the land we live on. And lastly, a really interesting one in Ghana. Illegal mining in Ghana is a rampant problem. It's actually in other countries in the African Regional Data Cube. This is not the only one. This is not really easy to detect because it happens rapidly, but the impact to the land and to the environment is devastating. So imagine this. Imagine a group going in. The first thing they do is they slash the forest and they devegetate an area that's probably 10 times the size of this room. We can find it. We can see it on the satellite. Devegetate it. Then they start drilling into the surface with a bunch of chemicals, by the way, some of which are arsenic and some of which are really dangerous chemicals. They drill into the ground, pull out all the minerals and the ore that they want, and then they grab all that, put it on boats, ship it down the river. You can see the river system. I'll explain this in a moment. After they leave, this all takes several weeks to a month. By digging, they get to the aquifers, the underground aquifers, which is the water. They use some of that for the mining purposes to bring the ore up. But when they leave, all those aquifers come to the surface. And what does it leave behind? A big round pond of water. And when you see these from space and you see these from aerial photography, it's just amazing. It is a highly contaminated small body of water that was not there a month or so ago. So if we could detect how this is moving, what are the patterns of this illegal mining? Where is it occurring? We know it's occurring along the river systems. So can we find this rapidly with satellite data? Can we look at the extent of how this is impacting the environment? And the water quality is just horrific when you see this. Actually, from space, these lakes are so contaminated, they look like bare soil. It's just horrible. So on the left is year 2000. So you see this narrow river network. And this area right here is, I think it's like a little town or something like that on the side there. It's just bare soil and things are dark. This is the networking system of the illegal mines. So look what they've done here. They want to ship this, when they tap into the mines, they want to ship it down the river system. So what they do is they create a path off of the river and they just keep mining, and then they end up reaching back here. So in the end, when the mine pops up here, they can easily get back to the river system. All that is illegal mining. All this is illegal mining. That's just an expansion of this town. Illegal mining all up there. It's really quite devastating. Well, what if I take this and I mask it? And I did a vegetation mask from one to the other. I just looked about nothing but the loss in vegetation. This is what that mask looks like. And it easily lines up with everything that's devegetated. Everything, including the little city that grew a bit, and the devegetation. And I don't know, yeah, I put a 13% number on there. Well, who cares about the actual number? It's pretty obvious there's a lot of things happening. So we're helping our friends in Ghana. We're helping our friends in Sierra Leone and other countries, Africa Regional Data Cube, trying to develop an algorithm that does a better job to detect this. Yes, this, as you can see, is pretty decent. I want to automate this. I want to make it a little easier, and I'd like to use a couple different data sets because these areas have clouds. Well, what happens when 3 months of the year you don't have a clear scene? That's when we need radar data. So if we can combine this with radar data in a data cube and get these answers rapidly, I think it will save a tremendous amount of time and resources in the investigation process and also help save their environment. And that is all. Thank you.
Thank you very much, Brian. So if you want to stay up just now, I'm just going to see if there's any quick questions for Brian.
Yeah, of course, good idea.
So, does anyone have a question? So can you say who you are and where you're from before your question, please?
Yes. I'm Benedict Mugambi. I'm working for the International Union for Conservation of Nature. I'm working on the red list of ecosystem. Thanks so much for this interesting presentation. You have been talking about different data sets about the land degradation, etc., so more related to terrestrial ecosystem, we'll say. But you have also information about marine ecosystem, for example, which is the degradation of coral reef, or which is the pollution of the coastline, etc.
So, yes, I didn't show any of those today, but there is, Australians do a great job. They have a number of algorithms along the coast. So they're looking at primarily two things. One is coastal erosion, so we can detect that pretty well. The second one is actually looking at the water quality along the coastline. The third one is bathymetry. You can do shallow water bathymetry with some of the data as well, because when the water is fairly clear, you actually get the optical scene. You can see the surface underneath the water, and you can look at bathymetry along the coastline. So you start to see changing coastlines, and it's really quite interesting. So many of these data cubes, even though they're primarily taken over land, when Landsat takes its data, it usually extends out past the coastline pretty far. So you get that coastal land interface. So there's a lot of interesting things that can be done. Didn't have time to show them all, but thanks.
Gentleman at the back.
Thank you, sir. I'm Ahmad Madawi, retired professor, University of Tehran, Iran. About the detection of the pollution in the water from the satellite, is that possible to make with what kind of pollution is that, for example, POPs or that? Is that possible to?
Yeah, so it is a difficult thing from space with some of the instrumentation we have, especially Landsat, to make a good water quality measurement. So I tell people, and I've talked with a number of scientists in the field to get an understanding of what can and we cannot do. With Landsat 7 and Landsat 8, I would say it's more of a qualitative measurement of water quality. So when I showed you that water quality variability, I wouldn't be caught up in the numbers so much, but qualitatively it does a very nice job. It'll tell you where the high sediment levels are and whether a lake is dirtier from one compared to another. What you have to be careful of is getting down into the nitty-gritty detail. What is the level of chlorophylls? What are the sediment levels, right? Some of the real core things that make our water poor quality. For that, you need higher resolution data and you need more bands of information. Now, Sentinel-2 has a few more spectral bands that are going to get us closer to good water quality measurements. So Sentinel-2 is going to be excellent when we get that in there. And the other one would be hyperspectral imagery. Well, there's not a lot of open hyperspectral imagery for large spatial areas. So we're not quite there yet for water quality. But I would say qualitatively, we can still do a lot to help our cause.
Thank you.
Sure.
Just on the last question, last week in Paris there was a session on kind of planetary data. So it was a policy science business forum held by UN Environment. One of Brian's colleagues, Ved, actually has some papers on this, so if you want more information on what Brian's described, that's available. So Wafa, and then the gentleman here, and then Rosemary. And I should just add, on the Africa Regional Data Cube, we actually have Amazon and Strathmore here, who are key partners, so Anna and Rosemary are here as well, so just to highlight you. Who has the other mic? Oh, well, Rosemary, if you go first, you just introduce yourself.
Okay, thank you, and thanks, Brian, for a great presentation. I just wanted you to explain the reason why Africa Regional Data Cube has actually been embraced by the ordinary citizen is the way it has localized the data to the ordinary citizen understanding. So the localization of data, how will that be able to be achieved in the next maybe 2 years, looking at the way, the speed and the pace in which Africa Regional Data Cube is going, and then the scaling and the building of skill and the kind of partnership with academic institutions like Strathmore University, pipelining of scaling for actually enhancing the Africa Regional Data Cube in the continent.
Yeah, I would say that's the challenge ahead. That's the biggest challenge. Would be, how do we scale this? How do we get this in the hands of many more users than just the highly technical people that understand, and build true capacity within the countries to do what I showed you here. I did many of those analyses very rapidly, and I'm trying to teach a number of people within the countries to do this as well. And I like to use my NASA line, it is not rocket science. It really is not that bad. But what we need to do is get people to have a general understanding of GIS information, a general understanding of what story is this telling you, and interpreting the data. So if we can, through Strathmore, Rosemary, and through your educational process, we give people some background in GIS information, how to interpret data, what's the difference between an optical data set and a radar data set, and how we use one versus the other. That basic core understanding is important to start with. And then we teach them a little bit about coding, the background of all of this, because if you really want to get some powerful answers, you need to do a little bit of coding in there, but it's not terrible. I was teaching my friend just yesterday, right? He was doing some Python with me, and he said, I think I can do that. We'll take it back and work on it. So we're there, but there's a challenge ahead. The challenge, I think, the data part, I was telling someone last night that probably a third of this problem is pulling the data together in this nice, beautiful, usable format. And we all think, oh, well, maybe that's all the problem. No, I think that's only a third of the problem. We've solved a lot of this now. This data cube makes the data easier to use. The 2/3 problem that remains is the true capacity building. How can this data be used? Can we train the people in all of these countries to really make sense of it and to use it and to build their GIS knowledge and interpretation? Then it truly becomes a powerful asset. That's where I see this going. And that's where I think the focus needs to be when we move forward. So when we go into Digital Earth Africa and expand this thing to all of continental Africa, it's not going to be so much about the data, because we're going to do a good job with the technical background, all of this. We're going to have to teach the people how to use it. And then it will be an exciting movement. Those there another?
Yeah, there's two more.
Yes, Wafa Abul Hassan from the United Nations office in Beirut, Regional Commission. It's very interesting. We want to bring this to the Arab countries. And I want to ask you, how do you bring this institution? Like, you do the work and you come to the country to tell them this is what we did, you want to be partner, or you do it the other way out? Because you want it institutional, and for us, we need the statistical offices to be part of this, so through GGIM and GEO with Steve to be part of this.
So I'll tell you how it has worked thus far. And unfortunately for some of my colleagues, I would describe it as a build it and they will come philosophy. Now, there will be many people who say, that's not how we do things in NASA. We start with requirements, and we define the requirements and what the users need, and then we build them what they want. Well, I don't think most of the world knows what they need. I think they look at that satellite data and they say, wow, that could probably help me. It looks interesting, but I'm not sure what to do and how to use it. So when I say build it and they will come, we build this core technology, we show them what it can do, and then I think it stimulates their minds to think about how can I use that to solve my problems. So it's sort of meeting halfway in the middle, right? When I go out to the countries, my primary thing to do is to understand what problems they're trying to solve. What's most interesting to them? We call them the use cases. Is it deforestation? Is it illegal mining? Is it the water? Whatever it is, then I can think about how to tailor some of these things for their use cases. So we've been working with most of these regional efforts and the data cubes. We've been working at the government level because we think that is the best buy. It's not necessarily, some given NGO or non-government institution. It's typically the government offices, because I feel like the statistical agencies and the governments and the ministries are the ones that are really going to take hold of this and decide, is this appropriate for our community? And then the trickle down will be probably to the university and the research system. But if I start at the research level, I don't think it has the same impact.
So Wafa, I was just going to introduce Philip, but Philip, you have to wait your turn because there's a gentleman here. Philip Thygo was instrumental in the setting up of GPSDD and the Africa Regional Data Cube, and he's on the steering committee of Digital Earth Africa. So Philip, we'll come back to you after we get this gentleman who was before you. We'll let him have his turn and then we'll come back to you. Please, can you introduce you? Can you say who you are, please, in your affiliation?
I'm Mazen Bakao from WHO, World Health Organization. Can you dig deeper? When it comes to, for instance, water, the example that you did, it's not just enough to look at the water at the surface where the images are. But there are usual models to do some expectation, what's going on as far as the third dimension. We face this when we try to model the air quality, for instance. Air quality tries to capture when it comes from satellite at higher levels where the air that we don't breathe. But we had to introduce another model, a chemical model, in order to go down scale and see. But
we don't, most of what we have, most of what we have in the data cube truly is surface knowledge, surface information. So I will say it's not impossible to get at some of that subsurface information. So you can do that with some of the soil moisture data, and there's a few satellite data products that penetrate the surface by small amounts. But I would say most of what you're talking about is in situ information. If you want to go quite a bit deeper and understand the aquifer system or understand what's happening with the river networks in and out of a water body. So there's probably more to it to solve the problem. I think the satellite imagery tells us part of the story, part of the picture, what's happening. That's the realistic change. Then to dig deeper and investigate, well, what's really causing this? That needs more data. It definitely needs more.
So we take
time for Philip?
Yeah, well, Philip, and then I have a question here from
good. From outside.
And his other question was just to comment on the previous one.
Who you are as well.
Exactly. Oh, sorry. Tingo Philip, I lead the data innovation at the Office of the Deputy President in Kenya. I think basically our take around this was simply, this conversation actually came out of a continental meeting that was supported by the Global Partnership, which GEO is part of the board. And the idea was we simply had a conference, and the idea was to understand what are the largest needs around the continent and one of them, of course, revolved around agriculture, mining in Ghana, water in Sierra Leone. So 5 countries came, and therefore there was a particular need. So it's not build and then come. There's actually a continental need and a demand. And then there was actually, and it was very high level basically. So it was basically presidents sending in ministers. And then there was, of course, already an agreement that the countries will help do this. And then, of course, working with GEO, and then working with Amazon Web Service, then looking at the capacity angle. So I think for me, this is why we love the data cube, to the extent that it's how countries and governments are prepared to work to contextualize. And you've seen the scenes that Brian has prepared, or actually co-created. So for me, that's the interesting bit. Even the pieces were not built and given. They were actually co-created. So I think for me, the data cube beyond simply being an infrastructure is actually a piece that enables countries to own the sort of the products that come out of that. And if you need us to come in, we can help.
Thank you, Philip. So we have one final question before we move to Jen. How does the data cube deal with agricultural applications like crop fields that require high-resolution multispectral satellite data? And that's from Swetha Killough online.
Good. Good question. I didn't have that example today, but we were just talking yesterday, right? The gentleman in the back from Kenya, we were discussing how to use this for agriculture. Well, I didn't show any algorithms today, but we have a number of algorithms for agricultural impact. Most of them are vegetation indices, NDVI, and Enhanced Vegetation Index, EVI. I'll tell you one example. I had ILRI, which is the Kenya Livestock Research Institute, came to me and said, I see you have this data cube. What I really need is this pastoral land where I have some grazing farmers and also for grazing livestock. I want to look at the vegetation over time, and I just need one index called EDI. So basically we cropped out this big area, created him this subcube of only this parameter that he needed, but he wanted it for 18 years worth of data. It's going to go off and it's going to do some analysis. Well, the analysis he hopes is going to show him where that livestock needs to be. What are the most vibrant sections of that grazing pasture land that makes the most sense? And a lot of it gets, soil related. The conversation I was having yesterday, I was saying, well, why is that? What's that diversity? He says it's mostly some areas have some good soil and some areas don't. And you don't necessarily know that all the time. Well, when you look at it from the satellite imagery, you can tell where the pockets are and what the historical changes have been. And so that's one interesting application. I also showed him another interesting application, which is something called phenology. Phenology is the study of the cropland change throughout the growing cycle. So imagine if I go into a cropland and I look at the phenological change from year to year of a certain type of crop growing. And if I look at maize that's grown in this section of Kenya and maize that's grown in another section of Kenya, phenologically I may notice that the cropping cycles vary and things are different. Well, is that a soil-based thing? Or if a farmer is wondering, what should I plant? Because I want to sell this crop and I want to maximize my output, he may have several choices. We could use satellite data to look at, in this region, what is the phenological behavior that gives me the best output. So there's some really interesting things that can come out of this. And what I hope is that by teaching the users in the area how to analyze this data, I can't think of all these solutions or problems, but I bet you will. And you'll be thinking, you'll get your mind spinning to say, all right, let me see, Brian taught me how to do this. I know I can apply it in this other way. So I won't be able to pretend to know all these problems that you come up with, but I'll bet you're going to figure out a number of really clever ways to use this data to answer some interesting problems.
Thank you, Brian. So a couple of things Brian said. He talked about computational efficiency, he talked about open access, and he talked about a quarter of the world using data cubes. So think about that, that's quite a staggering statistic. There's massive relevance for the SDGs. Two other points I think I'd add is, one, the UN Resident Coordinator activity that came out of UNDP. That's one of the things that we've been speaking to GPSDD about, using that network to expand the knowledge within the UN system of the data cube work and its relevance for the SDGs. The second thing is the indicator methodology, so things like 6.6.1, 11.3.1, those have been done in conjunction with something called EO for SDG, which is one of the parts of the GEO work programme. So there's about 50 different contributors, a number of countries, NASA, JAXA, the Japanese Space Agency, European Space Agency, UN Environment, UN Habitat, and a number of others, all the custodian agencies working on that methodology, which is obviously available for everyone to access and review. On the last one, on UN Habitat, that's a good example of where we're working with them to make sure that the policy also has language in it relating to Earth observations. So last year we put language into the Sendai framework under the Global Summary Report on Earth observations. So it's the first time disaster risk reduction actually had links to Earth observations. And now GEO, my boss, sits on the Global Assessment Report, the GAR, for the Sendai framework. So this is really important because this is us getting into the policy areas that help the governments have a mandate. So for the new urban agenda and the work of UN Habitat, which goes exactly to 11.3.1, this is another area where we're working. So we're trying to tie the policy activities to the technology and the solutions. So, thank you, Brian. Our next speaker, Jennifer O'Neill Oldfield, otherwise known as Jen. Jen's been at GPSDD for the last year and a half. The biggest accolade I can give her is I was on the review board that interviewed all the panelists and she won, so she was obviously very good. She worked for several years for the UN with UNDP and UN Global Pulse, and then latterly she worked in the Office of the Prime Minister in the UK. Now, if you know anything about British politics, that's no mean feat being involved in communications there. So Jen is going to give us, I guess, a communications perspective on all of this. Jen, please.
Thanks, Steve. And for those of you who are enjoying this session, just to say we have a session that's approximately 8 times as large this afternoon in DP World Hall at 3 p.m. So do come along, and people like Philip will be on the stage talking more about the Africa Regional Data Cube, but also we'll have perspectives from Mexico and Colombia and other places in the world. So do join us if you can. So communications people don't normally take the stage at events like this, but I just wanted to take the opportunity, since we have such a fantastic gathering of sort of creative and technical people, to ask you to help us use communications to show the power of data to improve lives. So they say that statistics are human stories with the tears washed off, and the context of people's lives are sort of flattened by large numbers, I'd say. So these sort of space-age satellites and data cubes and all these kind of techie things are so exciting for those of us who are geeky about this stuff. But the reason we're all here today is that we're more concerned with the end than the means. You know, we know this stuff is important, but we care about why it matters and what it's going to achieve. So, you know, that comes down to things like, as you've heard Brian talking about, healthier crops, clearer waters, less urban poverty, more tree cover. So it's no mistake that this is called the Eye on Earth Symposium. It sort of alludes to that human element and also a sense of protectiveness about the planet. So December the 24th this year, it's going to be 50 years since the Earthrise photo, which I'm sure most people in the room are familiar with. So that photo is the most influential one ever taken in an environmental context. And the power of that photo was, of course, the perspective that it gave us on the Earth, the majesty and the unity of our planet captured in a single stunning image. So just imagine from that single image in 1968, now we have these sort of petabytes of satellite data covering every square meter of the Earth, basically. So in communications terms, you know, technically there's an amazing effect, but in communications terms, we've sort of diluted the message, I think, a little bit. So kind of figuratively and sometimes literally, we can't see the forest for the trees. So I want you all to kind of come out of today thinking about the stories that appeal to you and how you can kind of share that message with the wider international communities. So we all know what's at stake if we don't sort of take action if we don't push these technologies forward. The UN report that was published last week was really shocking and a kind of stark reminder of what's at stake here. And, you know, we keep going back to that word storytelling. Basically, we need to kind of tell the story of why it matters. And it comes down to the simple kind of stories that our parents told us as kids. It's good versus evil, it's taking an adventure, it's solving a mystery, and it's falling in love. And how does that apply in this context? So please help us, you know, when you talk to people and they tell you these amazing stories like the ones you're going to hear from these 5 countries, tweet about it, talk about it, whip out your camera and record people talking about it. And let's get a kind of viral movement for this stuff going, because, you know, we're preaching to the choir here, but we're a small number of people. Each of us needs to go out and spread that message. So in the spirit of storytelling, I'm going to show a quick video. Those of you who were here earlier probably saw the first one, but we're trying to sort of capture people's imagination about the power. And then I'd like to thank NASA and Geoscience Australia for some of the imagery that we used in the video. Thanks.
Does anyone have any questions for Jen in terms of like her call to action that she's just made? Does anyone need help learning how to tweet? Does everyone know what Facebook is? I mean, it's a really interesting point. I mean, it's really hard to translate a lot of this stuff, like Brian was saying. How do we get this in front of the policymakers? And Wafa, your question as well. It's there's a big gap between the technology and the policy, and translating that is really important.
I think that is one of the appealing things of this sort of area, that, you know, it's so visual and many people are visual learners, and in this sort of digital age, then that's helpful to kind of sell the message in.
Davis is the Regional Director for Africa for JPSDD. When I talked earlier on, I talked about human interoperability and collaboration, and I think that's really Davis's job. He works with a wide range of organisations in Africa, and he has quite a strong background in terms of civil society. He worked at Civicus World Alliance previously, and now he's working with governments, with non-state actors, with NGOs. And so he's going to introduce the people who are heavily involved in the Africa Regional Data Cube. I asked someone for an anecdote about Davis, and the only thing I got was Davis likes to eat goat meat. So Davis, I'll hand over to you now for this session.
Yeah, the internet doesn't lie, so that's a fact. Thank you very much, Brian, Steve, Jenny, for that really captivating morning session. I mean, this first part of this particular session was basically to talk about, you know, more or less the supply side, I would say. You know, what is it that the organizing partners are doing to support these countries, I mean, through our collaborative that we're calling the African Regional Data Cube. I'd like to introduce my panelists. Please come to the stage. Benedict Mugambi is Senior Geoinformation Officer at the National Bureau of Statistics in Tanzania, and he heads the GIS work there. Fofana, she's a Senior Program Administrator for the Food and Nutrition Security National Early Warning System, or country start of the Ministry of Agriculture and Forestry. In Sierra Leone, we have Edward Opong Boama, who comes from the Center for Remote Sensing and Geographic Information Service, or SAGIS, at the University of Ghana. We have Major Andrew Nyawade, who's a space systems engineer from the Kenya National Space Agency. Thank you very much for finding time. Now, to be here, we are basically going to look at or hear stories from the country level, because it's often one thing to provide the technology and the infrastructure, but one of the things that we are learning, this takes time. It takes patience. It's quite a process. The reality on the ground is it's good to have the infrastructure and the data available, like Brian rightfully put it. But when it comes to integrating different components of the political and technical, it's a totally different thing. So there are policy and legal questions coming up in different countries. There is the coordinating mechanism that needs to be in place. We are thinking about how do we introduce other data communities that may not be part of government, but are really interested in the African Regional Data Cube or Earth observations data broadly. People are asking, in fact, I recently had a meeting in Nairobi with somebody who was asking me, now with this thing, can you actually see me in the streets? What is it that you guys actually want to do with this? You are giving me a very good story of what the data cube is and what it can do to government, but give me the other story. It's actually free. What's your real intention? Because there's no such thing as free lunch, as we know it. So there are all these different questions that you face when it comes to the country level, and you introduce something like this. And that's what GPSDD really is trying to do, basically bring all these different interests and communities and people to debate about those discussions, but also figure out how do you filter through some of the political and technical challenges and to practically apply this in a way that speaks to a broader audience. So we're going to listen to some interesting insights. I have some questions here, but how panels tend to go. If you follow some of these questions, you don't stimulate as much discussion. So it will be organic. We'll just listen to what they have to say. Major Nyawade here is going to talk about the Kenya National Space Agency and maybe more of the institutional arrangements that need to be in place, and probably some of the concerns that come up for the country. We have Bonnie, who's going to talk about, what is it that they are doing in Sierra Leone at a more practical, level, in terms of not only the institutional arrangements, but how they see this responding to some of the issues they've actually faced. The recent human slides, in Sierra Leone, real practical challenges. Benedict Mugambi has a very interesting story about the inspiration, and the approach in Tanzania is quite unique. Because what they've done is to figure out how do they develop use cases and then go to the policy makers, as opposed to going to the policy makers with a concept. We have this infrastructure, it's really great. Now we want to start using it. So what they've done is to start using it and then go to the policy makers to demonstrate value. And then we have Edward. Ghana has a very impressive institutional framework. We'll be keen to hear from you. How is that working? We don't have so much time. We need to finish at 10:30, but I'll leave this to you. So, Major Nyawade, in terms of the institutional arrangements in Kenya and how this is going to respond to some of the real practical challenges, go for it.
Thank you, Davis. Morning, everyone. Kenya has a very interesting scenario where most of the government institutions were established with traditional mandates since independence, and this is the job we're going to do. So they tend to stick to these mandates, despite the convergence of technology, the data overload, and all this. Now for us, Kenya, the priority is centered mainly around 4 areas, and we need to realize the objectives of these priorities sustainably. So one is food, nutrition, and security. This focuses mainly on agricultural production, fisheries, availability of water, then inputs that the government would provide. The other issue is universal healthcare coverage. This also is a factor that for Kenya we need to understand really at the lowest level where are our health facilities. How do we serve our people better in terms of health? Then there is the other issue of affordable housing in terms of urban planning, in terms of the resources for building. What effect they have on the environment? The quality side, how we obtain our soils, how we build our bricks. What impact is this having on the environment? So in a sustainable manner, we need to actually achieve these objectives as a government, but still ensure that we have something left for the future. Finally, issues of mining, manufacturing, those are also high on our priority list. And as a government, we are very keen to ensure that our economy develops based on these achievements. Further, there is a very interesting government framework where there are 47 smaller governments. Okay, there's a national government, and there are 47 other county governments, which have various functions. For instance, health and agriculture is devolved to those small governments. So as the national government, how do we ensure that we move together with the other 47 county governments? So ARDC is a very good platform to ensure that we are able to push agendas together with these governments and also be able to make the data talk to everybody. Thank you.
Thank you very much, Major Nyawade. And maybe just quickly tell us in terms of the institutional arrangements. You know, the Kenya National Space Agency is the overall coordinating. How do you see this working out in terms of bringing in other ministries, departments, and agencies?
Thank you. For an agency recently established, less than a year old, we have been having a working arrangement with the stakeholder ministries, environment, resource mapping and planning, mapping, science and technology. So we already have an existing framework, but it is well understood amongst the community that our main role would be provide the data. Thank you.
Fantastic. Bonnie, now for Sierra Leone, we saw the rate of urbanization. Recently, you held a hackathon that's looking at issues around urban waste and planning. How does this really benefit Sierra Leone as a country from your perspective?
Good morning. For Sierra Leone, we have challenges with deforestation, environment issues, illegal mining, and so on and so forth. So for us, the data cube is a blessing, as it helps us to harness geospatial data for policy decision making. So it's really good for us, and we are trying to get to using the product for better decision making.
Yeah, now the Environmental Protection Agency is actually here with us. I mean, one of the interesting things that's coming out is how the real practical challenges around urbanization in Sierra Leone, for example, waste management, and the recent hackathon that was held there. How is that helping to bring different institutions together to really think about how they can collaborate to solve those problems?
We had a hackathon where we came up with ministry, departments and agencies, civil societies, NGOs. We had a hackathon where developers came in to produce softwares for us, for both the Environmental Protection and Ministry of Agriculture, where we can use these softwares to be able to solve the issues we are facing with waste management for the environmental protection, because it's a huge challenge for us.
Thank you very much. I'm sure I'll come back to you. Benedict Mugambi, Tanzania has sort of grabbed the ARDC, so to speak, and is running with it. And of course, it's one of the countries that's really proactively and fairly aggressively, developing some use cases and products. Now, what are the stories that are coming out in terms of institutional coordination, the level of interest among its policymakers, and how you're organizing yourselves to pull this off?
Thank you very much, David. I'm Benedict, and I'm working for National Bureau of Statistics in Tanzania. Sincerely speaking, we didn't know before that there is anything known as open data queue, but we came to know it. I think it was in August this year, and where I had a conversation with Davis, who connected me to Brian. And when I spoke to Brian via Skype, and then I said, okay, this is very, very fantastic and very interesting. And then Brian asked me, which part of your country would you like at least to have the images that you can make analysis and see exactly what is really happening on the ground. We have a problem with the deforestation in some of the our forests in my country. So I picked one of the forests, and then I sent the coordinates of one of the forests, and then Brian made some of the analysis, he worked on it, and then sent back the images. And then I said, because I can see some of our politicians, especially ministers, they are always suffering from the data. And then I said, okay, if that is the case, we scanned that image, and then we went together. The National Bureau of Statistics, people from Ministry of Natural Resources, and some other ministries, just for clarification, for verification about the deforestation. And we found really it was really interesting. And from there now, I asked again, Brian, if we can now, starting now, moving on, training us on how we can use the open data tool. And of course, we had a training, I think it was last week, for 4 days. And then of course, we invited many people there from different institutions, academia, for they attended, all of them. And of course, they are very much interested to make use of the open data tool. And we have now to come up with a sort of like the work plan, the map road, how we can now keep moving and make sure that we have to utilize this open data tool. And recently, I think it was on Thursday, when the National Bureau of Statistics was launched, was releasing the environmental statistics. And then we invited the guest of honor was the Minister of Environment. And then of course we had to show at least what is really happening in the open data group. And then the minister was really interested. And then of course he said the next session for the training, he has to be there to see what is really happening. The essence of doing so, the essence of inviting these politicians, we are missing, we have the data gap. We have the data gap and we don't know how we're going to fill the data gap. And we are trying to find a way on how we can use this geospatial technology, the tools to have the data to fill up the gaps that we have. For example, the area on the deforestation issue, the area on the agriculture. And of course, for now, we have already discussed the issue about on how we can use this data at least to reduce the prevalence of HIV and AIDS. There are several major towns in my country. It's not possible to identify these major towns without using the technology. And once we are going to have the data showing this major town, it's very, very possible, again, overlay with another data, for example, the new major town. Is there anything about the service delivery point? Is there anything about maybe people, of course, who are suffering from HIV and AIDS? So we need to see on how we can utilize this data that, of course, can save some of the implementation and maybe even to change or maybe to come up with a good policy. You know, a good policy depends upon the data. Good policy depends upon what is really happening down on the down to the community party. So this is what we are in fact trying to dialogue. And I have a lot of messages. People are really eager. They want to have to speak or maybe to communicate directly to Brian, but in fact it is not easy anyway. And we are trying to see on how we can use like this. We are many, people are many, but we have to find the modality on how we can promote in this area so that we can make use of the open data group. Thank you.
Yeah, thank you so much, Benedict. I mean, one of the response we have to that as GPSDD is that we are recruiting a GIS technical manager to be based in Africa. So this is somebody who's going to be working very closely with Brian, to provide the day-to-day support on the RDC. But what we also hope for is some form of sustained capacity development program, which we are already discussing with Brian, to think about how we can train super users, either in Tanzania or spend some time with Brian at NASA. And then these super users now will come back to the country. And this will be the people now that will continually train others and troubleshoot and of course refer any challenges they may be facing to the GIS technical manager or to Brian and his team, and then try again to resolve those. In terms of the challenges with the infrastructure itself, the data cube, I know we've done some virtual training. So what would you say, I know it's always good to hear the good stories, but what are some of the challenges in terms of accessing the infrastructure itself? And I'm sure Brian will speak to how NASA is continually learning and improving on the infrastructure itself.
Yeah, I think the problem of which you're having now in Tanzania, we think maybe many people, they just enter into the system, that when we're trying to use the data, the data in the data group, the access the access to come up with the end product is always complicated. It is maybe because of the internet, or maybe there are many people who are getting it, but what we need now is that if there is a possibility whereby maybe a sort of control, or maybe if you can add something whereby once we are in there and then to come up with the data, the speed of making the data available very quickly, that would be much better. Because sometimes if you visit a site and if it takes longer to execute the data, sometimes people may be getting worried and maybe lose the interest to get the data. So that one has to be worked on and then come up with a solution.
Yeah, Amazon Web Services is actually in the room, but I'm not looking in that direction. So Edward, over to you. What's the Ghanaian experience of this?
Okay, so I'm Edward from Ghana. Since the introduction of this African data open queue, Ghana also has been part of it. And over the months, since we are training from May, we have been able to use it on several key states. From the presentation that Brian gave, he gave one on illegal mining. It's one of the issues that is really affecting Ghana, because within this activity, not only do they degrade the land, but every activity on the land is spoiled. The people living within those communities are also affected. Their water bodies are also affected. So it's a very serious issue in Ghana. And with Brian's support, we have been able to generate several methods to monitor this. Just last month, we were able to also get Sentinel data on board to help us monitor these activities on the ground. And it's a very great achievement from Open Data Cube. So to keep this thing running in Ghana, what the technical team, which the big and special data work stream made up of, is trying to do is right now, we are trying to let the other ministries also get on board into this data queue. So next month, there's going to be a training for 50 selected people from different institutions so that they can also use the data queue in their daily work. At the end of the day, if they also bring their data source into the system, it will actually help us get enough evidence and also enough support to monitor these activities on the ground. And that's what right now is happening in Ghana. Can I move on to the challenges?
Yeah, sure.
So far, some of the challenges you face, some of them, what Mugambi just said, also, you're also experiencing such things. If a lot of people get onto the system, it actually slows down, and it takes a time for it to process activities. And also, getting the imagery visualization is not a problem, but classifying it, interpreting it to the larger audience, because most of us are not GIS experts, it's kind of difficult to explain. So through this training, I think gradually we are getting to the position whereby not only will we visualize it, but you can explain it to even the civil people to actually understand what is happening to their community.
Thank you so much, Edward. How is political will in Ghana really driving the process forward? And what are some of the difficulties you've seen with institutional arrangements in Ghana?
Okay, so for last 3 months, we used DataCube to do an urbanization in one of the districts, that's Tamale. And after processing everything, we showed it to the Vice President of Ghana, and he was amazed. Like between 2000 and 2017, how the urbanization has actually increased. So he asked us, "What can you use the census data to complement it?" And I said, yes. So it was provided, and it was wow. Then if this is what is happening, then they also have to be on board to support us. That's why we are letting the other institutions also come on board, so that they can actually also use it.
In terms of, you talked about the Vice President now being interested in this. Have you seen any tensions between organizations in the coordinating mechanism? Or you're all, one big happy family in Ghana?
After the training, then you can actually see the tension between them, because it's not exposed to everybody, just around selected people for now. But right now, you're happy, a happy big family.
Sierra Leone, are you a happy big family?
Well, we are trying to be a happy big family, but it's really difficult. Calling people to meetings and, they come to meeting once, twice, then they just, so you keep calling them, you keep running after them to come. We are trying, we'll get there.
Brian, do you have any specific question?
Yeah, I wanted to comment, one of the themes that I'm hearing is, some of the challenges we've had in this training session, which we have to get better at, this capacity building from, in doing it remotely, right? It's hard to fly around the world all the time. I travel a ton as it is, and we're going to try to get some of these experts. A local expert would be great, somebody that you can rely on and count on. But just this whole idea of scalability. We have these systems running, so they have a dedicated Amazon instance that they use, and when we're in a training session and there's 10 or 15 people there, and inevitably if we say, all right, start with a really small area, just 3 or 4 people, all of a sudden 15 people, big areas, it can bog down the system really rapidly. Whereas yesterday I was running some analyses with a fella from Kenya, and they were running lightning fast. He says, how are you doing that so fast? Well, because I was the only guy with the system, right? So we have to think about how do we best scale this, and these are things I'm going to be working with, talking with our Amazon friends about how to make this more effective operationally. Because we live in this world of instant gratification, right? We want to look at our phones and we want everything to be quick and we don't have time to waste. And so I'm the same way. When I push the button on the screen, I want to see something in a few minutes. And if it's going to take me an hour, well, I'm less interested. So we'll work on that. That's my job. I'll ask a question back to you, and it has to do with just general capacity building. Are there challenges that you've seen within your organizations of people really understanding the message from some of these images? Do you think we need more core training regarding, you know, optical imagery and radar imagery and just GIS core training? Or do you think that we need to focus a little more on the technological aspects and coding? I'm just kind of curious what your thoughts are on what your needs are from a capacity building.
The imagery interpretation is a bit of a challenge, even with the technology. So we need more capacity building on those.
Thank you very much. In Tanzania, we have several GIS expertise, and for example, in my office, we have 12 guys that train GIS, and they have mastered just for technologies issue. But I think, of course, if a new thing's coming, and maybe the capacity building is very important also as well, because these things have been coming very recently. And secondly, also, the other part also is also very, very important. If you can go for both, to me, I think doesn't harm anything.
Okay, so going for both is a good option, it's a great thing, but starting, if you can start with the core GIS, it will be very great, because that is the fundamentals, and it will actually help us to move on to the next phase.
My name is Maria Ivanova. I'm at the University of Massachusetts in Boston, and thank you very much for this very stimulating morning session. I have more a reflection rather than a question, because throughout the morning we heard the use of data for policy, and that you can present data to the policymakers and they can start making decisions. And I see the need for various capacity building exercises to get to that point. But I can also suggest that we think of using data to test the effectiveness of policy. And that might also capture the imagination of ministers, especially, and of other policymakers. So, for example, right now in Dubai is also the COP, the Conference of the Parties of the Ramsar Convention, is taking place. And in the next session at 10:45, we're going to talk about this index on environmental convention implementation and effectiveness that we have developed. And we have now developed a measure of the level of implementation of countries of the various conventions. And I can see of now using data to test whether if you implement that policy, you actually attain the environmental impact. And I think this is where policymakers really have a gap of we create policies, we implement them, but we don't know whether they solve the problem that they were designed to solve. And so I can suggest even to GPSDD also as a framing is let's not only use data to create policies, but let's use data to test the effectiveness of various policies. And then just getting ideas on what policies to test, whether it's wetlands or forestry or agriculture, would be something that can really help with the communications, it can really help in the SDGs agenda.
We saw an example in Australia, just to follow up on that. They show it often. There was there was a reservoir that they were concerned about water quality. So they actually put some water quality restrictions in control, and then they monitored it with the satellite data for the next 10 years. You could see a dramatic difference. It really was an interesting way to see the policy worked. And, yeah, so those kind of things.
Do that for wetlands.
My name is Samuel Mohamed Kamara, the GIS Director for the Environment Protection Agency in Sierra Leone. I think back home, we have a greater number of GIS experts, but what is happening is that people are working in silos, and then there is, the government employment is not as much encouraging, so they go more into the private sector, where they practice in their own way and they get contracts. What we want to see in the future is that how best GPSD can help us bringing in these talents together, then pushing them to work more for government, and because one of the greatest things that we have a lot of projects, but most of them are in duplication. You see a project coming on, and then expertise come, and then the technology transfer has been the most difficult thing. Because most of the projects that have been sponsored by international donors, they come in, they are experts, but they put little emphasis on training of the locals. So at the end of the project, everything goes back. So like you see, the projects are left as white elephant. So one of the key things our government is pushing, how best we put more emphasis on the technology transfer rather than even getting the product at the end of the day, because it is more easier for us to do better jobs if we have the expertise within country than bringing in, flying in all the time, getting people on board. So these are one of the greatest things that we are looking out for, and that is where we need more support. Thank you.
Yes, there's Peter from the French Development Agency, data scientist. I'm happy we've talked about capacity building. I was actually expecting to have a demo to find out how the user interface really looks like, okay, to see how we can, okay, so what is the role of donor institutions at this stage? What can we do? Thank you.
Thank you very much. We need money. We need cross-country collaboration, but more importantly, facilitating. I mean, there are different ways to look at this. First of all, raising the interest of donors in geospatial, data and information, and how this has a more practical utility, because it's through that interest that the money will follow. Nobody wants to put their money in something that's not working. So we count on people like you who have been exposed or are interested to speak amongst other countries and other donors to say, this is something revolutionary and we can actually do it at scale. Then of course that's the second point, scale. We want to do this across Africa. You've just had demand from the Arab region. So how do we scale some of the methodologies and applications and the tools in a way that then will help many other regions? I'll stop there because of time and hand over to Steve, who actually stood up to basically tell me like it's over. Thank you very much for your attention. Let's clap for
So if you go to DP World Hall at 3 p.m, there will be a much broader discussion which will have more of the policy elements and UN involvement. So UN Environment and UN Habitat will be involved. So that's at 3 p.m, DP World Hall. And you can also get a lot of the information at data for SDGs.org, or you can come and speak to any of us. So thank you very much for joining and participating, and enjoy the rest of the day.